start with data processing. So, so what is data processing? That is something we need to understand before we actually go towards it. So, what exactly is data processing? So, do anybody have any idea? What do you think? And can all of you tell me what do you think about data processing? You can paste your comments in the chat. I'm looking forward to hear from every one of you. What do you know about data processing? What do you think about data processing? Okay. So do paste your comments in the chat. I'll be looking forward towards that. So I'll continue for now. So why what is data processing and why it is very important? So you all know like machine learning, all these things. It's a part of automating the things. So we want to uh, make the machine, or we want to introduce some intelligence to the machine so that it can understand the data and it can get some insights from it, and it can take its own decision. Okay. So that is what the end goal of machine learning. So for that, data is a crucial thing where we need to uh, uh, put into the model and then get some insights from the data. So in order for the model to understand the data, it should be in certain format. It should not have any errors. So like again, it is not a human, right? It can't understand if there is some error in the data. So whatever the data that it has been given as an input, that it will process like in terms of how it understands the data. So that's the reason data processing is very important. So we need to make sure when we are sending some sort of data to the model that is accurate and good enough for the model to understand and get insights from it. So that is a purpose. So that is the main reason why we use data pre-processing. Okay. So without any proper data, so model will not be able to understand data properly, and it will give wrong insights, obviously. So that's the reason data pre-processing is very crucial step for any data analysis or for any data manipulations in machine learning. Okay. So we need to clean the data, we need to transform the data into understandable formats, and we need to organize the data in different categories so that the model will be able to understand data and get some better insights from it. Okay. So in data pre-processing, there are many steps that were involved. What were they? So these are some major steps that were involved in data pre-processing. So one is importing the library. The very first thing is we need to import the libraries. We need to load the data. We need to handle the missing values. We need to handle categorical data. We need to handle feature scaling. We need to handle feature engineering, data splitting, data normalization, data visualization, and pre-process. And finally, some pre-processing steps at the very end after doing all these steps. So with all this combined together, we will get the final set of data where we can send it to the model direct. So these are the major steps as part of data pre-process. I'll explain you each and everything in detail. Let's start with libraries. So what are the libraries that we usually commonly use to pre-process data? So for that, we'll be using Python. As you know, this lab is completely based on Python, data mining using Python. So I'll be talking about the libraries that were used in Python. So some of the major and most used libraries are Pandas, NumPy, Scikit-learn. Okay. So what are Pandas? So again, it's an open source library. So it was developed for data manipulations analysis. Okay. So take for example, we have an Excel. The Excel have rows and columns. The same way in pandas, we can organize the data in rows and columns. So that is an additional advantage that we have in pandas. And so here we can also access the data which is of type series. Okay. So I'll just show you one example of how we can use pandas, how we can load the data to pandas and all. I'll be showing those examples, but before that, you need to understand what pandas is. Okay, so it was built on top of the NumPy arrays. You know what arrays are, right? I hope you all are aware of arrays, single dimension, multi-dimensional arrays, 2D arrays, all these were aware, right? So same array, the library will going to use those kind of arrays and store the data in the form of a list. So that is called as a data frame. So when you load the data into a data frame, it will segregate the rows and columns with some unique name for it, and that is what we call it as uh, an actual data frame, where it fits all its data in rows and columns. And this feature is supported by the Pandas library. Okay, so I'll show you an example for you to to understand in a better manner regarding Pandas. So again, it's a two-dimensional label data structure, which uh, which has rows and columns, uh, similar to what you see in a SQL table. Like you know what SQL tables are, right? SQL tables are rows and columns. Both were involved in. So in the same way, like data frame is also such kind, which represents this SQL tables. Next is a series. Series is a one-dimensional array, it's a single array of some size. Okay, it's a simple series. Next is some of the features that we have in Pandas is data manipulation. So it has numerous number of multiple number of functions that were developed for filtering, for selecting, for sorting, for merging, and for transforming the data within Pandas. So that is one of the important features that were required when we are trying to manipulate the data. So that's the reason this library is most used uh, across different preprocessing tools. Next is if there is any data that is missing, or if there is any data that is uh, of different kind from the other, it is easy for us to identify that kind of that row, and we can easily remove that row from the entire data frame. So these are some of the common features that we have with pandas. So I'll show you one example of how pandas work. So for that, I have taken some examples from ChatGPT. I can show you that. Let me quickly reshare my screen to show how pandas will load the data. Just a second. So I have okay. Let me take a simple data set. So I'll not go for a big one. I'll take a simple data set. So to import pandas, it's very simple. We can say import pandas as PD. So it's a you know what import is. I don't need to explain you about import. Pandas is a library name, and as represents aliasing. So I don't want to use my keyword pandas all the time. So I'll simply use some aliasing and give a short form of it. So generally we use PD in normal in general. But if you want to use something else, or if you want to use just A, you can use A. This aliasing name is something which is up to you, but it's just an aliasing name. So I don't want to use my entire library name all the time. That's the reason I'll be doing alias. So this is how I import the library. So once the import is done, I need to load the data to data set. For that, I have just taken a sample data set. So this is my data set. I have just processed it. Now I need to import my uh, data to the data frame. That is what I'm looking for, right? So here a df is what this is one of the snap sample example, as I said. So df is a variable name. So I will be loading my data to the data frame using the pandas library. So that is what my goal was. So for that, what I need to do is, so I'll be giving some name. Let's take, uh, okay, for now I'll take df only. Df equal to PD is the library name, PD dot. I'm calling it as a data frame. I'm calling the function data frame. So using the library, I'm calling the data frame function, and then I'm loading my data, whatever which I want to load to the data frame. Okay. So within this function, I'm giving my data as an input. So in this library, uh, within pandas library, I'm calling my data frame function and I'm giving data as an input. It got processed. And then if I print it, so you can see my data, it's a object and list of, it has different objects, and each object is a key and the value is a list again. So this data is directly went into the data frame as a form of rows and columns. Every row will have an indexing and column will have the object names according to the objects. So that is how I'll be fitting my data to the data frame. Okay. So now I have read the data and I've kept it in my data frame. What else I can do? I can do some manipulations. How can I manipulate? Using the object names and all, row names and all. For that, it's just straightforward again. So I'll give my where object name and I'll just give the, data frame name, and I'll just give the object name. Here object name will be fruit. I'll get only column one fruit. If I say color. So now if I try to run this, what will happen? It will fail because I can't understand what exactly color is, because all the objects, names and rows will be in the form of strings here, not as a object name again. Okay. I should be giving it as a string. If I give it as a string, then it shows the data. So this is how I load my data to the data frame. And then this is how I'm going to handle the data and then process the data according to my needs. So this is as part, so this is how we are going to load the uh, CSV data to the data frames. CSV data or any object JSON related to data. I'll be going back to the presentation. There are many other things that I need to discuss. Okay, so I've just given a sample example here in this presentation. I'll go to the next slide. So this is those are some of the characteristics that we have with pandas. Like it could based on top of NumPy, it was developed. It was an open source, and it will be used for many data manipulations, data operations, because it has this library includes multiple such features. Okay, and that's the reason we'll be extensively using pandas in machine learning, and especially for data preprocessing and data manipulations. Next is NumPy. NumPy is also again another most frequently used library. For NumPy, we are going to so NumPy is also uh, uh, most as said most used library across for data preprocessing. So it provides support for multi-dimensional arrays, 2D, 3D, 4D, multiple dimension arrays will be supported by NumPy. So along with some mathematical operations, which are very effective and quick enough. So we can do many mathematical operations as many as can, and the operation will take less time than compared to the usual operations. So that is an advantage that we are going to get with NumPy. So it has a collection of multiple functions. You can go through all this. So that will be available open source. You can just check. Okay. So within this, based on top of this NumPy, the pandas or scikit-learn, all these libraries came into picture. So NumPy is a root for all this. So some of these features that we have in NumPy are, as I said, it's a multi-dimensional array supported. So ND array supported. Next, many array operations like algebraic operations or element operations. Each value in a number is called as an element. So element operations, statistical operations, all these are possible in NumPy. Next is broadcasting. So it has a very it NumPy, as it is a multi-dimensional supported, it will support different shapes and sizes. So any kind of dimensions we can create using NumPy. So that's an advantage with NumPy. And the last thing is the integration. So the low level languages like C, C++, or Python, Fortran, all these we can integrate this NumPy with all these libraries. So that is an advantage that we are going to get with NumPy. So that's the reason it is most frequently used across. So again, similar to how we load the data in NumPy, we can also load the data in Pandas. How we have loaded the data in Pandas, we can also load the data in NumPy. I'll be showing you that example as well. As we have imported Pandas as PDF, for NumPy also we have a similar way to import the data. Let's say import NumPy. Again, NumPy is a library name, as is for aliasing. You can give whatever name you want in place of NP. Regular people normally use NP, but as whichever name you are comfortable, you can give this name. So this is not a mandatory thing. So this is a library name, and this is aliasing keyword. Okay. What I'm doing a array data here. So let me do that. NP dot array of. Let me give some random numbers. I think I can't copy from here. I need to. Okay, let me copy. I'll be copying few data sets later. For now, I've given randomly. So now, so you can see I have loaded the data into array data into the NumPy using NumPy, right? Let me print and see how it looks. It shows an array of some type. Uh, but with the data which I'm given as an input. Now I need to, as I said, it supports multiple operations like addition, subtraction, anything is possible. Here, one of the operations that it has, you can see here is it has done square roots for the array. So I'll be simply doing some multiplication of 2. Array 2 equal to array. So again, it's there are many operations that are possible in NumPy. So you can simply do addition, subtraction, square root, whatever it is possible to do. I'm just adding 2, and then I'm going to print array 2. You can see for each element, 2 is added, and then you can see the output. So it's again for array 3 equal to array, so this is how it is. Like we can many operations are possible. I can't list out all the operations here, but all type of operations are possible with NumPy, mathematical operations. So you can also see some mean, median, mode exam operations are also possible. Okay. So this is what NumPy is. Let me go to the next slide. Next is scikit-learn. So do anybody of you know what scikit-learn is? Any idea? Okay. So again, scikit-learn is a most frequently used most used library in machine learning. So it's a very efficient tool for data mining and data analysis to extract the features, to apply multiple algorithms. So it was also there were also multiple algorithms that are supported by scikit-learn, such as basic algorithms like clustering, regressions, classification, dimension reduction, many more. So again, scikit-learn is built on top of NumPy and SciPy and Matplotlib. Matplotlib is a library for visualization, and there are many other Python libraries. On top of this, NumPy was scikit-learn was developed, and so the base, the root was on top of NumPy and Pandas. So based on NumPy actually, NumPy and Matplotlib. Based on these, the actual scikit library was built. So some of the key features are consistent interface, extensive documentation. So like this scikit-learn has a huge community support where if you have any question, it is easy for you to get the answers from the community. You can simply go to the community page and you can pose some questions, and as it is an open source and a huge community was there, you can simply you can easily get the data from other users. So that is a very important. In other words, a documentation. It's a kind of documentation. Okay, and model evaluation. Scikit-learn also provides different metrics, different functions, algorithms to evaluate the performance of the models. So that I'll be showing you how we can do all those things when we try to build a model and try to assess the performance. I'll be talking about all those things. And most importantly, for pre-processing and feature extraction and feature engineering as well, it provides many libraries. So that is some of the advantages that we are going to get with scikit-learn. So I have just given us some examples of scikit-learn here. So I'll be talking about this in detail in the coming sessions. For now, you can just take it as a reference. I'm not going to run it at this point. So this is what the very first step is. We need to import all the libraries that are required. And I've just given a very high level brief about Pandas, NumPy, and scikit-learn. Just go through. It's very easy to understand. Do let me know if you have any questions in the next session regarding the libraries. So once the libraries are imported, what is the next step that we have seen earlier? Next step that we have seen is loading the data, right? So we have the data, but we need to load the data to the library. For that, we are using this libraries such as Pandas and NumPy, right? We are using these to load the data to the library. Now, what kind of data we can load? So there are many formats that we can load data. Some of the most frequently used formats are CSVs, Excels, JSON, and SQL. SQL is also one of the good uh, option to load the data to the data frames. So I have given some snapshots from Google to how to load the data to CSV. For now, I don't have a file ready. I can't show you these examples, but it's straightforward. You need to have you need to have a simple data file. It could be Excel or some text file or something else. Just simply have a data file. So import your library. Next, create a variable, and using the library name, use the function read underscore CSV. This is the function, and you can give your data set name. It's as straightforward as that. And simply load all your data to the data frame. I think I can show you one example. Let me see. No, I don't have any data file at this moment. So yeah, you can give a try. I don't have a data set at this moment. I'll leave it there. So this is an example for a CSV format. And now this is an example for Excel format. You can say import the library, use the library name and call the Excel related function and give the Excel file name. And if the Excel has multiple sheets, you can give the sheet name and you can simply load the data to the data frame. Okay. Next is importing the JSON format file. Same. Read dot underscore JSON. This is a function. Give the JSON file name. You should be able to read the data. Next is SQL. So when you have, again, I'm not going to go deep into SQL, what SQL is, how you can get the data, what are the queries. I'm not going to go deep into it, but I'm going to tell you what are the libraries that it has. So in Python, for us to integrate with the SQL database, we use a library called SQL HP. Okay, SQL ALCHEMY. Okay, this is the library. This we will be using this to import the SQL or to get the control to the application from the SQL. Okay. In other words, we are going to try to establish the connection to the SQL using this library and fetch the data from the database from the SQL. So that is what we are going to do. And this is a library that is supported in Python to establish the connection and to gather the data from the database. Okay. For that, from this library, we are trying to import some create engine and we are giving the database name to establish the connection between the Python code and the DB server. And then we are writing a query here, and then we are putting the data into the data frame. Okay. So this is what our SQL does. I mean, how our Pandas does to read the data from the SQL. So this at this moment, I don't have any demo, but I'll give you an example regarding this, how we can establish the connection and how you can write a query and put it into the data frame. Okay. So this is how we are going to import your data to the data frames. So now, once we have loaded the libraries, once we have loaded the data sets, next thing we need to understand is we need to identify the column names. What are the independent column names and what are the dependent column names? What are those? So dependent variable. So dependent or independent variables. What are dependent variables? So dependent variables also known as response variable, outcome variable, or target variable. So when you're trying to predict or explain or understand something, that is what we call it as dependent variable. Because based on some other variable name, your outcome is dependent, right? And that's the reason we call it as a dependent variable. I'll not take go through all this description. I'll give you one simple example. You know y equal to mx plus c, right? Y equal to mx plus c, where m is a slope and c is an intercept. But y is dependent on x. So if x varies, y will also vary. So y is dependent on x. So y is called as dependent variable. X is called as independent variable. So that's a very best example for you to understand. But when it comes to machine learning, you need to understand what are the dependent and independent variables. It's completely based on the model that we are going to develop and what kind of data that we have. It's completely based on that. Okay. So how we can identify that? I'll take a simple example. So you are trying to do a drug test. Okay, drug trial. So you will be increasing the quantity of each and every chemical within the drug, and then you will be testing on the patient's body, right? So here, patient health is an outcome which is a dependent variable on the quantity of chemicals that you are using in your drugs. Okay, so that is one example for the independent and dependent variables. And when it comes to machine learning, so let's take you are predicting the house price. Okay, predict whether uh, a particular house cost based on the number of floors, number of square feet, area, locality, all these things. So based on all these things, you need to predict the cost of a building, cost of a house. So here the cost of the building is dependent on many factors. So dependent variable will be cost, independent variable will be your number of floors, area, locality, all these things. So in simple terms, independent variables are something which you can tweak as per your choice, whereas dependent variables are something which are which are directly dependent on the independent variables. Okay. So that is how we need to understand what independent and independent variables are, and then you need to classify them. Okay. So any questions so far? Okay. I'll continue. So now we, as I said, we have imported the libraries. We have read the data to our data frames. Now we need to see what is the data that we have. Do we have any missing data in it? All these things we need to see. How we can see. As I was saying, again, our pandas will support multiple features to have a missing data in it. Okay. For that, what we need to do is, so let me have a good example here. However, I can still, um, no, here also I don't have a good data set with missing data. Just give me a minute. I'll put some data set with missing data so that I can run and show you how it is. Okay. So I have a data set now. Let me show you this. Just taken some random data set from uh, Google. So this is my current data set. Okay. So where I have an employee ID, age, salary, and department, and you can see in the salary, first in the second row, we have a NaN value, which is not up unknown or no value. Okay. And in the department, in the third row, we have an NaN value again. So these are all missing data. Now we need to drop this data or we need to fill some data with this. So ideally, if the data set is very huge, so it is recommended to drop the data so that the model will try to understand the data in a better manner. So first of all, to check whether there are any missing values in the data set or not, we just need to run a command is null off, and that will tell you what it is. Let me run and show you. So now DB, now you have your data frame. What I'm trying to do is I'm trying to uh, understand if there are any missing columns that were there in my data set, right? In that process, either you will be able to find the data set, or you need to understand what are the different wait, just a second, there is some glitch. Yeah. So you need to understand what are the different columns that you where we have none values, and what are those. All these things you need to understand, right? So for that, I have to use or I can use is null function that is provided by the pandas directory. Okay, let me write this function for you. I'll simply print it, and then we can so this is how it is. What we are telling to the data frame is, in each row and each column, if there is some value which is not uh, empty, or which is empty, then return it as true. Okay. In the first row or first column, all the values are there, so it is giving false. In the second column, the first row has none, so here it gave true. Third row, third column, true. Fourth row, fourth column, true. Remaining all I have the return, so it is giving us false. So this is how I'll check if my data frame has none values. Then I am going to print how many values. So now this is a very small data set. It's easy for you to look at it. But if it is a huge data set, how we are going to run? How we are going to see? So this is what it is. If it is a huge data set, and if you do is null of, this function will give you true or false, and dot sum of will tell you how many columns has null values. So in age column, we have one row with null value. In salary column, we have one row with null value. In department column, we have one row with null value. So this is what dot sum of will tell you. And then once you get the dot sum of, then you need to decide whether you need to drop the columns, or we need to fill in something. So for now, I'll tell you how to drop the columns. So for that, you need to use drop now. So this is a function which you can directly use to drop the columns. So it's again very straightforward. But drop now will take axis, which tells us whether it is a row or a column. So based on that, it's going to drop the values. Okay. Uh, let me run. Let me show you that first. The okay. So my data frame. So you need to understand what each and every line is, and then that will be easy for you to write it as developers. So in my data frame, I have a function called drop now. So I'm calling that function. And in that column, I am saying access. As I said, access represents whether it is a row or a column. So for now, if it is a 0, that means it refers to row. And if it is a column, it refers to column. Okay. I mean, if it is 1, it refers to column. Access equal to 0. So I am saying whatever the values, I mean, whichever rows has 0 value, remove that row. So that is what I'm saying. And I am saying in place as true. What is in place? In place means what are the changes that I am doing now, it should be applied within the same data frame. So that is what in place represents. And if I try to print this, I got only 0 and 4. Remaining all, I have 3 values, all the all the rows got dropped as I have used access here. Let's take, let me run this once again. Okay, now I'll say 1. So only employee ID got dropped because remaining 3 columns has 2 values. So that is the difference between access 0 and 1. Okay, any questions? So this is how we are going to drop the data. Now, once the data is dropped, what next? Next is we there are many things and here again. If you now we have decided to drop the data for for a given reason. So when your data set is really good enough, or that means really huge, dropping is a good option. But if your data set is small, again, based on the problem statement, you decide whether you need to fill the data in that missing columns or you will simply drop. Okay, you all know. So the reason why we don't data is you all know how data is important here, right? So if the data size is less, the prediction of the model will not be accurate. So that's the reason we need to see how appropriate is it to drop the columns before we actually go ahead and drop. Okay. So if we don't want to drop, we have something called imputation. So that is one of the technique where we can implement the values uh, uh, in place of mixing columns. Like for example, I can calculate mean of the entire row or entire column instead. Mean of the entire column and fill in that data, median or more. One of these I can compute for that particular column and I can fill in the data. Otherwise, I could go for forward filling or backward filling. That means wherever the value is missing, I can go to the previous record or the next record of that particular column, and I can fill in the data. Okay. Other thing is predictive imputation. That means you can use some machine learning algorithms to predict the values, and you can fill in the data. So all these are some of the ways to fill in the data if we really want to fill some data in the missing value space. Okay. Again, that's a bigger concept. I'm not going to going deep into it. I'll just for now I've given some info. It is called as imputation. Using this technique, we can still fill the data in the columns where the data is missing. Okay. So now we have also removed all the columns with all the rows or columns with 0 values. So far we have done some part of processing. What is the next step in the data pre-processing stage? Handling the categorical data. Again, so it was a proven fact that machine learning model can perform better if the data it has is a normalized data. That means whatever the data it is getting as an input, it should be of same kind. Then machine learning performs better. So that is the reason we are required to do some category to handle the categorical data. That means so we need to rename this data into, I mean, not rename actually, adjust the data, adjust the weights, and then send it as a input to the model. Okay, and then the model will try to understand it better. So I'll give you some good examples here. So you can see here in the snapshot I have provided. Again, it's from ChatGPT. You can go through the snapshots later. So you have small, medium, large, medium. So this is the data that I have. So there's a repetition of data. What I'm going to do, I've created a map where I'm saying uh wherever I see small, give the number as 1. So small will be the key and its value is 1. So that will be replaced in the data set. And the same will be applied in the data frame. And same, wherever I see medium, replace it, place the value as 2. Wherever I see large, place the value as 3. So this is how I am giving like I'm giving some normalized values for my data set. So this type of filling is called ordinal encoding. So using ordinal encoding is a technique where we externally map the type of or category of data to some constant. Okay. Any questions? Okay. If there are no questions, then I'll go to the next thing. So once so this is one type of encoding for handling categorical data. Next is one hot encoding, which is most frequently used. So here I have a same data set, red, blue, green, red. What I'm going to say is pd dot get dummies. I'm going to give my data frame and I'm going to apply the column, in which column I need to apply. Let's take, for example, my data frame has uh, here I have 3 different colors. So in the new data frame, after running this command, in the new data frame, I'll get 3 more additional columns. Okay, 3 more additional columns of red, blue, and green, which will gives all zeros and one values to tell you how many 0 and 1 values are there. Okay, let me I'll drive you to the example which I'm trying to refer, so that it will be easy for you to understand what exactly it is. Okay, so I have a data set to show you. Let me paste the data set first. Okay, this is my data set, fruits and colors, and in my data frame, I mean DF data frame, putting my data into the data frame. And in the new data frame, I'm creating one more data frame. I'm saying pd dot pandas dot get dummies. This is a function, and I'm giving my data frame name. And then I'm asking my data frame encoding should happen on this column. Okay, that is what I'm asking. And then I'm trying to print the data. You can see in the fruits column, I could not see any uh, encoding. But whereas, as I have applied this for colors column, here you could see uh, color orange, color red, color yellow. What are the unique values that I have in this particular array? Those many columns will be created, and wherever you have that particular value, that column will be filled with 1. So here in the for apple, it is red. For apple, it for orange it became 0. For yellow, it became 0 because these 2 columns are there in that particular array. So that's the reason these columns are created, but the values are 0. Whereas red is the one which have the value. I mean, the apple is in red, right? So that is its corresponding value. So it got filled in red. One got filled in red column. So this is how you are going to encode your data. So the target or the source column, how many unique values we have, those many additional columns will be created in the data frame. And the values will also be filled accordingly. So sometimes for a 3D array or some array, so you might have multiple colors for the same fruit. So for multiple colors, it will be multiple columns. Take for example, red and yellow, both will be filled for fruit, apple. So that is how it's going to fill the data. Okay. So this is what how one hot encoding is. So we are going to make everything from everything into zeros and ones using one hot encode. Okay. So next, label encoding. So again, our label encoding and all these again based on the need basis we will be using. I'm not going to go deeper into it. It's just one of its kind, like one hot encoding. Just go through. I've just included for you to refer, but not it's not that. It's just one of the one of its kind, such as like one hot encoding. So you can simply use this. Okay. So next is frequency encoding and targeted encoding. These are also one of its kind. You can just go through. I have just placed here for reference. I'm not going to go deep into this. So with this, we have also categorized the data that we have. So now once the categorization is done, we need to scale the features. Okay. So how we can scale the features and what exactly the feature scaling means. Okay. So before we actually go to feature scaling, I'll just go to the previous slides once again. From this list, we have just seen how we can import the libraries, how we can load the data, how we can handle missing data, how we can handle uh, identify independent and dependent variables. And then we have also seen how to handle categorical data. Okay. Now we are going to see feature scaling. What feature scaling is. Before we actually go into feature scaling, do anybody have any questions so far regarding data handling or categorical data? Okay. If there are no questions, I'll go to the next slide. Next is feature scaling. So again, feature scaling is the process of transforming this entire numerical features in your data set to the similar scale. As I was saying, right? So the if the data, input data, is in the same format, uh, then it is easy for the model to understand the data better. Okay. So that's the reason we'll be doing scaling. So for that, we have two different techniques. One is standardization and normalization. What is standardization? Which is also called as Z-score normalization. What was that? So it's going to scale each and every feature um, where we have the mean as zero and standard deviation as one. Okay. So that is how it's going to scale each and every feature. For example, you can see now the formula here is z equal to x minus mean by standard deviation. Okay. X is the feature that you have at that particular column. So mean is a mean of entire column. And then standard deviation again is a computed standard deviation for the particular data in the particular column. Okay. So when you apply this formula, you are going to get a normalized value that we are going to put it in a data frame instead of the actual value. So using the normalization value, we are going to train the model. So that in simple terms, so we are going to remove the threshold checks and other things. Take for example, my data set has a values from 100 to 200. It should be ideally. But there are some columns with zeros, which will make my model to predict come up with the wrong predictions. So to avoid these kind of cases, I'll be doing this normalization technique, whether it could be standard normalization, I mean, Z-score normalization or min-max scaling normalization. So I'll be doing this normalization technique to remove the filters. So of some threshold below and above, I mean lower threshold or higher threshold. We'll be removing the threshold, the corner cases and all. And we are trying to normalize the data that we have, that we are going to give it as the input to the model. Okay. So this is why we are doing feature scale. So again, so this what you have seen is standardization, whereas min-max scaling is also something similar to that, but it will be between 0 and 1. The fixed range will be 0 and 1. Here in standardization, it will be using mean and standard deviation. The value will be between mean and standard deviation. The mean standardization between 0 and 1. But here the actual value will be between 0 and 1. So that is the difference between standardization and normalization. Again, it's all based on the topic that based on the data set that we have. I'll be showing you few examples of how this like normalization will be done. Just give me a minute. So let me take few data sets to show you the standardization. Yeah. So this is my data set. Now I need to load this data to my actual data frame, and I need to stand normalize this data. So that is the target. So for putting into the data frame, you can simply say df equal to underscore data frame of data. Why it is showing an error? Because data frame is not identified. F is capital. And then I'll see my data frame is reflecting properly on 30 head. If your data set is huge and if you run DF like this, your entire runtime will be, runtime for running this cell will be huge. That's the reason if you want to see only the header, you can simply say header 1 or header 5, only 1 or 2 columns just to see data is appropriate. Okay, so for that you can use the df dot head off and give the column numbers, how many columns you want to see. Take for example, here it is only 5. Let's take 6. We will still give 5. Okay, I'll say -1. It will give 1 less than the actual size. I'll say -3. It will give only 2. I'll say -10. It will give nothing. So that is how it is. Okay. You can just play with this. Okay, to see the header and all. So I have loaded my data into data frame. Now I need to standardize this. I mean, normalize this. For normalizing, I can use standard scalar is a library that I need to use. Is a function that I have to use. For that, I need to understand from where it was. You can go through scikit-learn library from where that particular function was. Actually, it is from sklearn preprocessing library. We have that, so you can simply import. Okay, from sklearn is a library where we have all the scikit-learn preprocessing. Okay, import. So from sklearn, we are trying to import uh, our particular standard scalar. Okay. So what the standard scalar is a function to normalize the data. So you can simply say import standard scalar. So now it got imported. That means I have access to standard scalar. So what I'm doing now? Now I need to train or I need to standardize this data to see how normalization is happening. Okay. For that, I'll simply use scalar equal to standard scalar of. I'm just calling, I'm creating one more function to standardize this data. Okay. Any questions on this? Okay. Let me run and show you this. Um, yeah. What did I do? I've just called the instance of that of my particular standard scalar function. And now, after getting the instance, I'm going to transform my data. How I'm going to transform my data? I can simply use pandas.dataframe and I can use the instance of the standard thing, and then I'll put it fit it my frame data frame to it, and then I'll mention which all columns I need to normalize. So this is what I'm going to tell from a program or from a Python program to standardize. Okay. For that, what I need to do is I'll take my data frame after, after standardized. What are the data frame that I have? That data frame. To that data frame, I'm saying in my pandas library PD, I have a data frame which we need to fit this data, whatever we are giving it as an input, and then transform. For that, I can say data frame, the frame of, and then we need to fit the data. Scalar dot fit. Okay, we are trying to fit whatever the data that we have taken as input earlier, and then we want to transform that. To fit and transform, we have a function called fit underscore transform of the previous data frame, whatever we have, df. So that holds the value, right, of the data set. So we will be using fit underscore transform of df, and we need to say which all columns need to be transformed for us. So for us, we need all the columns. We'll say columns equal to. So we need to mention what are the columns that we need to be that we want to transform. So here I want everything, so I can just simply say df dot columns. Okay, now let me print the df. So this is the actual data and this is the normalized data. So you can see the summation of first column will be 0, or the summation of second column will be 0, will be between 0 and 1. Okay. So that is how we are trying to normalize the data into a unique format so that the model will be able to understand uh, and give accurate predictions. So one thing you need to remember here is you have uh, two types of techniques: standard scaler and min-max scaler. For standard scaler, the the mean and the mean and for standard scaler, the mean will be between 0 and 1. Okay. And the standard deviation also will be between 0 and 1. Whereas for min-max scaling, the mean and median will be between 0 and 1. The direct values will be between 0 and 1. So that is the difference. Just try to understand that this will be little confusing for standard and min-max scaling, but it is again, it's not that difficult as it looks like. Okay. Any questions so far on feature scaling? Okay. Once the feature scaling is done, next thing is feature engineering. I'll tell you what feature engineering is. Let me go back to the presentation. So, what feature engineering is? Like feature scaling is something we are trying to normalize the data, the actual data that we have between 0 and 1. Now, feature engineering is something we are trying to add few more columns, and those columns will be filled with the existing columns that we have, and then extract data from it. Okay, that is what feature engineering is. So I'm not going to go with all this theory and all. I'll directly give you one example about feature engineering, and then you'll be able to understand. Okay. So let me get back to this. Yeah. So what I'm going to do? So let me get a data set for you to show you a good example on feature engineering. So this is the data set I have just copied. Okay. This is the data set I have. Let me put it in my data frame. Let me put it on data frame. Okay. So this is my data that I've kept in my data frame. Now I have to use the same features which are available here, and I have to create new columns for my model to understand better. Okay. For that, I can create a BMI column because I have height and weight. the data in my BMI column should be, you should take weight, okay, divided by height, okay, df of height, okay. Okay. Whatever mathematical equations, I'm not giving exact equations, but I'm just, yeah, this should be fine. This is the exact equation. So for, I'm creating a BMI column by taking the weight and height. For that, I'm using my weight 60 by height 160 by 100. That is 1.6 to the power 2. Okay. So if I do this, I'll get the BMI for this particular height and weight. I've ran it. Let's print and see. So one more column BMI is created with BMI index. Okay. So I have extracted a new feature from the existing features. So these columns are called as features, and also called as independent variables or features. So from the existing features, I am able to create a new feature called BMI based on height and weight. So this is what we call it as feature engineering. Okay. So this we'll be doing again based on the data set. I'm creating one more column. So I'm using weight again. It's equal to, I'm taking few gains. Variables. And I'm saying underweight. When I'm trying to print. So what I said is, if my weight is between 0 to 65, it should be underweight. And if it is between 0 to 75, it should be normal. And if it is beyond 70 to 75 to 85, it should be overweight. So that is what I am saying to my particular data frame. And you can see as it is 0 to 65, what are the ways we have 0 to 65? It has underweight and 60 to 70. That means, okay, 75 this is, which comes under 65 to 75. So it will come to normal, and 80, which is 75 to 80, which is overweight. So that is how we are going to categorize this data. So basically categories that we create for classification kind of problems, but we can do this feature scaling and engineering based on the existing columns. Okay. Any questions so far? I hope you are aware, you are now aware about features engineering and feature scaling. Okay. So now I'll go back to the presentation. I'll go to the previous step. So we have gone through import libraries, loading data, handling missing data, handling categorical data, feature scaling, and feature engineering. Then the last step is data splitting. So again, data transformation or transformation, again, it's all comes under feature scaling. Okay. Data visualization is something which I'm not going to discuss now. It's just visualizing the data. It's not important at this point, but we can discuss later. But visualization is something which I'm not going to tell you now. And then only the last step is data splitting. Now we have the data set. Now we need to split our data set into test and train sets, so that we can train the model on the test data set, and then we can split the model. Okay. So this is just a second. So I have also included some additional feature scaling techniques that I have gone through the net. Some you can just go through later. It's just for your reference. It's not, but just feature scaling is something we can tweak or create new features from the existing feature. So now we have all the data set ready, and part of pre-processing is also done. Now we need to create the test and train data sets. How we can create the test and train data sets. So for that, in the NumPy, we have something called random. Okay, let me show you a good example of what splitting the test and train data sets. I'll go here. Okay, yeah. So, so now we have all the data ready. Now I need to split my data into test and train sets. So generally, most of the models use 80-20. 80 will be the test train set, and 80 will be the train set. 20 will be the test set. Again, it's based on the model and kind of data we have to divide that. I don't say 80-20 is always the right, but it was most proven 80-20 is a good ratio. But again, it all depends on what kind of problem we are trying to solve. For that, now I need, what are the data that I have? I need to split that into test and train sets. So let me also take 80-20 as a ratio. So in the scikit-learn library, we have model selection within it, function, sublibrary, something. Okay. From there, I'm going to import test train split. Okay. So this is a library which I'm going to import. So once the library is imported, whatever the data set I have, I need to divide that into test and train. Train, test, train. Can someone tell me why I'm doing X, Y, X train, X test, Y train, Y test? Why I'm doing this? Because my data has independent variables and dependent variables. In my training set, I should have all the independent variables and its corresponding dependent variables as a training set. And the next test set would be on the train model. We are going to give few more inputs which are not part of training set. And for those inputs, the expected output, what it has to be, we have to receive that as part of the prediction. So then we'll be able to evaluate the metrics, evaluate the performance, evaluate the accuracy. Okay. So that's the reason we have to divide both X train, X test, Y train, Y test in using this library, train test split library function. I'm going to give my X and Y. Here I don't have X and Y data sets. I can say test size. Test size is a variable which holds what is the ratio. I'm saying 0.2, that is 2:8 ratio. I mean, uh, 20, the data set size is 10. 2 will be on test set, 8 will be on the train set. Okay, 2:8 ratio. And then random. So it should be randomly driven. It should not take any particular range. Okay, so that is what I'm expecting. Uh, Random state some. Oh, so we can give and we can simply run this. It gave an error because I don't have X and Y. Let me put some X and Y data. Let me go back and bring the data set. So I've just taken some random data from internet. I'm going to paste it. So it's then I'm going to run this. Y should be capital Y. Okay, now we can print the test train splits. So earlier it is uh, like 0, 1, 2, 3, 4, right? If I print the DF 0, 1, 2, 3, 4. So as we have given 0.2 from the 5, 0.2 will be 20 is to 80 ratio will be only one record. So in the train set, 0 is there, 2 is there, 3 is 4 is there, but 1 will be in the test set. You can see 1, 2, 7. So that is how we are going to divide the training test splits using the scikit library that we have, or existing library that we have using this library. And then we'll proceed with the model, building the model and running the performance and all, evaluating the performance. So this is all I have for today. I have just gone through some of the pre-processing steps, how we can pre-process the data, like loading the libraries, identifying the dependent and independent variables, and dealing with missing data. We have dropped all NaN values in it. And we know how one hot encoding to categorize the data. We can scale the features by uh, doing some normalization, standard normalization, min-max normalization. And then we have divided the testings. So we have gone through these two experiments today. Just do some hands-on and let me know if you have any questions. Okay. Anybody have any questions so far? Okay. If not, we can close the call for today. I'll let you know if you have any questions in the next session.